In this video, we're going to look at permutations. So permutations is the study of arrangements. When you have a set of objects, you can arrange them in different ways, and permutations are just the different ways that things can be arranged. So here's a question that says, how many ways are there to arrange the letters A, B, and C? So we want to arrange them in an order, or in a list. So one way is just to write A, B, C. Now, we could actually just list them all here, and that's quite easy to do when there's only three objects. For example, if you have A at the front, you've either got A, B, C, or A, C, B. And we can be systematic here. If we have B at the front, then the only two options are A, C, or C, A. And if we have C at the front, then the two options are either A, B, or B, A. So it turns out there's 6 options here. Now let's think about how we could have figured that out without listing them all, which we wouldn't want to if there were lots of letters. Well, we've got space for 1, 2, 3 letters. So let's think about how many choices you had for your first one. Well, you have either A or B or C, so you've got 3 choices for your first letter. And then once you've picked one of these, well, there are only 2 options remaining for your second letter, and once you've picked that, there's only 1 option remaining. So you have 3 options, and then 2 options, and then 1 option. So this is going to tell you how many choices you've got. 3 times 2 times 1 is 6. A final way to visualize this is through a tree diagram, saying our first letter is either A, or B, or C. If we choose A as our first letter, our second letter is either B or C. If we choose B as our first letter, our second letter is either A or C. And if we choose C as our first letter, our second letter is either A or B. And finally, if you've chosen A and B already, you've only got C left. In this branch, you've only got B left. In this, you've only got C left. In this one, you've only got A left. In this one, B. And in this one, A. And so there's 1, 2, 3, 4, 5, 6 different unique branches. And the calculation to figure that out is to see there were 3 branches, each of those branched into 2, and each of those just had 1 branch, so 3 times 2 times 1. Now, we've just developed a mathematical notation for this because 3 times 2 times 1 is also called 3 factorial. Now, this pattern continues for any number of distinct objects. If you have n letters or n objects, you can arrange these into n factorial different arrangements. So let's see how we can use that logic in a couple of questions. How many anagrams are there of the word factor? Okay, so an anagram is just an arrangement. Don't worry about it being a real word of English. Let's just accept any arrangement. Now, every letter in factor is distinct. We'll come on to repetitions later. So how many letters are there? Well, 1, 2, 3, 4, 5, 6. So that means there are 6 factorial different arrangements. And 6 factorial is 720. Now, we can just use that fact, but what you'd be imagining is that your first letter, you have 6 options. There are 6 different things you could choose for your first letter. Maybe you choose C. And then that leaves only 5 options for your second letter, which might have been R, for example, and so on. And then you kind of pick your remaining letters, and you've got 6 options, then 5, then 4, then 3, then 2, then 1. So 6 factorial arrangements of factor. How many anagrams are there of the word factor that begin with the letter R? So if we add that restriction in, if we pull out our R, well, what's remaining? We've got 1, 2, 3, 4, 5 options left. So the question really now is, how many different ways are there to arrange the 5 letters in the first 5 letters of factor? So there are 5 different options, so it's 5 factorial. And so we have 120 different anagrams of factor that begin with the letter R. So that's an introduction to permutations and how we can use factorial notation to figure out the number of arrangements when we have a list of unique unique elements like letters.